So, how do you think you did? Well, your mathematical computations and reasoning are important skills to answering the last questions. Also, are you ready with your own questions? Here we are now. With me to field my questions are Mike and Zach. And shown on your set are the numbers to use. Now, please note that the telephone numbers are good only for today's November 10th broadcast. All right, let me begin. I've got a number of email questions that have come in, so I'm going to start with the email questions. My first question, if you take a look at it, is what is glide ratio? Mike or Zach, who'd like to answer that?
I'll go ahead. The glide ratio, as you saw earlier, is the ratio of the horizontal distance flown to the altitude drop. Now, from a design standpoint, we look at the glide ratio as the result of the aerodynamic efficiency, which is basically the lift versus the drag ratio, or L over D. So when we design an airplane, glide ratio is important. That's a measure of the aerodynamic efficiency and how good the airplane is.
All right, we had a question that was related to that. If we look at our second email question, someone wants to know, does weather affect glide ratio?
It certainly can. In fact, when earlier you saw the wind and the rain, those are two factors that very heavily, in fact, impact the glide ratio. The more wind that you have and the higher the rainfall, the more likely you are to have not as good a glide ratio.
Okay, so wind speed could be a factor here then. All right. Well, I know that we have a caller out there, so caller, how about giving us your name, please, and your question? Go ahead, caller. Can you give us your name and your question?
Michael Williams, I'd like to know,
All right.
how far could the first airplane that y'all showed go?
Could turn down your set and ask the question again. I think we would hear it a little bit more clearly. Could you repeat that again, please?
That's the phone doing that.
Okay. Could you ask the question one more time then, please?
How far did the first model go?
How far did the model go? Are you referring to the student's model?
Yeah.
Well, you saw there on the data that they collected that it went, they tried it 10 times, and we saw their data for 5 times, and you saw the distance for 5 of those flights. So your challenge is to go back and look at that data, and you could calculate the mean and the median for those 5 flights, and then you'll have that answer. Good question. All right. Well, let me go back to my email, because I know I've got several questions that have come in here. Here's a question. How do researchers in designing an airplane decide what its wingspan should be?
It's a good question, Shelley. It really depends on the aircraft mission. Typically, transport aircraft have very long wingspans where they need high fuel efficiency. For fighter type aircraft, you typically have shorter spans. You require a lot more structural strength out of the airplane. So you typically have a short span on fighter type configurations.
Okay. All right, we got another email question that's kind of related to this. All right, and maybe you've answered this already. How important is the width of a wingspan in an airplane's performance?
In a very simple sense, I guess the longer the span, typically the more fuel efficient an airplane configuration would be.
Okay.
So that's why you see long spans on commercial transport airplanes.
All right, well, I know we got another caller out there, so let's go ahead and go back to the phones. And caller, could you give us your name, please, and your question?
Yes, my name is Eric Morgan. I have a question for them. My question is, the little perforated holes, or the little holes in a golf ball that help break down wind turbulence for the golf ball, will that help on a plane's wing to reduce drag?
Ooh, good question. Who wants to take that one? Mike? Zach?
I can do that one. As you know, the little dimples on a golf ball helps change the drag of the golf ball by creating turbulence. Now, in fact, there's a similar system that can be applied to transport configurations called hybrid laminar flow control, where in fact there's little holes that can either suck air in or blow air out that helps to create a smooth layer of air near the surface of the skin. That actually can reduce the drag of the airplane as much as 15 to 16%.
All right, good question. Did you want to add something else?
Yes, and actually a very similar application that's developed here at NASA Langley is a turbulent drag reduction in the form of what we call riblets, which are fairly rough surfaces along the airplane, which actually reduce the overall drag of the wing.
All right, well, that's about all the time we have. So I'd like to thank all the guests that contributed to this program, including Mike and Zach, Paul, Karen, and Sharon. I'd also like to thank Jones Magnet Middle School, Dare County Airport, AirVenture 98, and Hoot Gibson, who did win his race. And finally, the Smithsonian National Air and Space Museum. Just a final reminder to check out the Shapes of Flight website, where you will see, hear, and learn more about today's topic. Also, we invite you to camp out with like-minded students in our special virtual aeronautics camp. No sleeping bags required, just some creativity and mathematics and science know-how. Videotape copies of this show, along with the lesson plan, may be obtained from NASA Central Operation of Resources for Educators, or CORE.